Weird. Okay, I don't know if you guys can see my face today, but I'm gonna fill out these notes. So this is for our start of our new unit. We have Unit 2, and our first lesson today is on functions. So the first thing we're gonna just say is that we can represent relationships between inputs and outputs in multiple ways. So like inputs are what we mean when we say like our x value, and our outputs would be our y value. So we can represent relationships in ordered pairs where we have, this is our x comma y. Oh, that must be what I did. X comma y. So each ordered pair is written that way. We can also represent it in a table. Maybe if I zoom in, this will help. Sorry guys, writing is just not working for me. Alright, x comma y. So then we can represent those in a table. So I'm going to just take these same numbers over here, and I'm going to input them into my table. So the first ordered pair, we had -3 was my input, -5 was my output. The next one we had -1, 9. The next one 0, 7. -3, 3. And then 6, -5. Now that same table, you might also see tables like that written like this. Don't let that trip you up. All we're going to do is our x is going to go in this column, so we're going to write it -3, and we're just going to go sideways with it. So -3, -1, 0, -3, 6. Then the same thing is going to happen with our outputs. So we're going to start from the top and work our way down. -5 is paired with -3, 9 is paired with -1, 7 was the output for 0, 3 was the output for -3, -5 was the output for 6. Okay, so the two different ways we can see our table, we have our ordered pairs. We can also graph these. So I'm going to go ahead and graph these points that we can see up here. So the point -3, -5 means I'm going to go to -3 on my x, and then down to -5 on my y. -1, 9 means I'm going to go over to -1, and then up 9. We have 0, and then 7, so over 0, up 7. We have -3, 3, so -3, up 3. We have 6, -5. And then that was it. 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points. Okay. The next way we can represent ordered pairs is what we call a mapping diagram, where we just draw arrows connecting the input to the output. So -3, the output was a -5, so I'm going to draw an arrow from the -3 to the -5. For -1, the output was 9. Again, -1, 9, or you can see it here, -1, 9, or you can see it up here, -1, 9. So I'm going to connect an arrow from -1 to 9. Then we had 0, 7. I'm going to connect an arrow from 0 to 7. Then we had -3, 3. -3, 3. So again, because the -3 put out two things, it has two arrows. The last one was 6, -5. Right? 6, -5. So now my 6 will also come up here to -5. Okay, 4 different ways, all representing the same relationship, which was this set of ordered pairs, this set of input and outputs. Now let's talk about what a function is. And we're going to look at saying whether this is or is not a function. And we'll do that by looking at all these different types of things. So some relationships are also functions. Now, a function is a relation where every input has exactly, and I mean exactly, one output. One and only one output. Now, a way I like to think about this is like a soda pop machine. So like, let's say you were at McDonald's trying to get pop, and if you push the Coke button, you would expect to get Coke out. If you push the Sprite button, you would expect to get Sprite out. You're pushing a button, you are getting one thing out. That makes it a function. Not a function would be like if you pressed the Coke button and then Sprite came out, because you're pressing the button, you're doing this input, which is pressing the button, but it's spitting out something other than Coke. It's spitting out two different things, both Coke and Sprite, therefore not a function. So like, let's look at these actual examples here. So here I have 1 and the input is 3. Here I have 1 and now it's putting out a 0. I have 1 and now my output is a -2. So every time I'm pushing 1 or putting in 1, I'm getting out a different number. So this would be not a function. Again, because even though I am putting something in, it is giving me a different number out each time. This is like pushing the Coke button each time because I'm pushing the same number 1 button, but it's giving me 4 different types of pop. So not a function because each input, because my one input, again, because I'm putting in a 1 each time, so there's only one input, is giving me 4 different outputs. 3, 0, -2, and 8 are all coming from that same input. Okay, let's try this next one. So here I have an input of -2. I'm getting out a 1. Putting in a -1, getting out a 2. Putting in a 0, getting out a 3. Putting in a 1, getting out a 4. This would be a function, and this time it is because each input has exactly one output, right? I'm putting in a -2, I'm only getting out a 1. I'm putting in a -1, I'm getting out only a 2. There's not another -1 anywhere in here giving me a different number. Here, this is the only time I see an input of 0, and I'm getting a 3. So each input is giving me only one number out. Here, again, I have a horizontal table now. So we're reading it up and down like this. -2 is my input, 1 is my output. -1 is my input, 1 is my output. Now, this one is a function. Even though we see 1 a whole bunch of times, just like we did up here, the difference is up here, 1 was my input. So my input was giving me different outputs. Again, a function, every input has one output. Here, my 1 input gave me 4 outputs. Down here, I have an input of -2, and it's giving me a 1, and only a 1. Here I have an input of -1, and it's giving me only a 1. There isn't a -1 anywhere else up here giving me something else. So you can see the same output. What we can't see, what would make this not a function, is if we saw a -2 up here again, this time spitting out a different number like 0, because that would be like pushing -2, getting Coke, and then getting Sprite. So again, it's okay if we see the same outputs repeat. What's not okay is if we see the same inputs repeat with different numbers. So again, this is because each input has one output. Even though the output is the same, that is fine. Here we have a graph. This one would not be a function. For graphs, there's this really easy test called the vertical line test. If it crosses once, it's a function. If it crosses twice, it's not a function. So all you do is you draw a vertical line, which is up and down. If you draw a vertical line, line up and down at any point on this, if it crosses twice, it's not a function. You can already see right here and here, it crossed it twice right here, and it crossed it twice right here. So we can draw vertical lines anywhere on here, and no matter what, it's going to cross twice. So this is not a function because it does not pass the vertical line test. Again, because I can draw a vertical line and my vertical line crosses my graph twice. Lastly, this one would not be a function because, again, when we have these mapping diagrams, this is your input, this is your output. You can see that my input of 5 gives me both a 2 and a 4. So anytime you see 2 arrows coming off of one input, that's going to mean it's not a function. For mapping diagrams, in order to be a function, each of these numbers should only have one arrow coming off of them. So no, because the input 5 has 2 outputs, 2 and 4. Okay, and then lastly, choose a number n that would make this relation not a function. So here we have inputs, here we have outputs. I want to know what number would make this not a function. So remember, not a function would be when you have an input that gives you 2 different things. So -1 right now is giving me a 5. So if I put -1 here, now my -1 is giving me 5 and 11. So that would make this not a function. I could input 0 here. 0 is giving me an 8. 0 is now giving me 11. My input of 0 is giving me 2 different things. So when in doubt, if you repeat one of these numbers, more or less, you'll probably get one that's not a function. However, if we did 1, that would be a function because 1 is putting out an 11 right here, and then we're pushing 1 and we're getting an 11 again. This would be like pushing Coke, getting Coke out, pushing Coke, getting Coke out, because it's giving me the same output. So the only way that this would make it not a function is instead of 11 we had something else. So you need to be careful of that. So for this to make it not a function, we can make it -1 or 0. Alrighty, I know it's a little weird, it's a little funky, but I just want you to try your best. Let's see, that was all I had here in your notes. So now you're on independent practice. Again, come back up here to look at these examples. We did examples with ordered pairs, one that was a function, one that was not a function. We talked about the vertical line test. We looked at a mapping diagram. So you should be able to do these okay. Use those past examples we did to help you. Look through these tables. Again, remember here to draw your vertical line. Here, look to see if you have arrows coming off any numbers twice. Okay? Give it your best shot. And let me know when you finish so I can check your answer, and then go ahead and take your mastery check.